In this video, we're working on lesson 2.2 and we're on page 32. And we are going to be working on some problems where our quadratics are written in intercept form. And so this is intercept form here, where you have our quadratic written as factors. So you'll see parentheses, usually in intercept form. And the reason we call this intercept form is because we can find the x-intercepts easily when we are looking at the function. So remember, the x-intercepts, those are when your function has a y value of 0. Right? And so whatever these numbers happen to be, whatever p and q is, your x-intercepts will be p and q. Because if you were to plug p in for x, this would cause you to get a y value of 0. And if you were to plug in q here for x, that would also cause you to get a y value of 0. So our x-intercepts will always be located at p and q. Okay, so you get your x-intercepts right from here. Okay. And then once you find your x-intercepts on the graph, you can find the axis of symmetry by taking the average of those. You know, the axis of symmetry will be in the middle of our x-intercepts. And so to find the axis of symmetry, you will take the average by adding up p and q and then dividing by 2. So that is how we'll find the axis of symmetry. So we're going to turn the page to page 33, and we're going to try these in number 4 and number 5. So in number 4 and 5, we're going to graph the function, label the x-intercepts, vertex, and axis of symmetry. This one is in vertex form. Okay, so it makes it nice and easy for us to find the x-intercepts. So you have x plus 4 as one of the factors and x minus 3 as another. And your x-intercepts will come right from here. Right? So one of your x-intercepts is negative 4. Watch out, it's opposite, right? So you can kind of think about it this way. You're asking yourself, what would you plug in for x here so that this plus 4 is 0? So your x-intercept is negative 4, right? And then from this factor here, our other x-intercept would be 3, right? If you plug 3 in for x, 3 minus 3 is 0. That makes this 0. Okay, so we have our x-intercepts at negative 4 and 3. I'm going to go ahead and plot those on my x-axis. So I know one point on my parabola is at negative 4, 0. I'm going to label that. And another x-intercept is at 3, 0. I'm going to label that. Once I have my x-intercepts, I'm ready to find the axis of symmetry. I know that's going to be in the middle. So to find that, I can take the average of my x-intercepts. So my axis of symmetry will be located at x equals, I'm going to add my x-intercepts and divide by 2. Take the average. When I do that, I get negative 1/2, or I'm going to keep it as a fraction, so negative 0.5. If I think about where that is here, negative 1/2 or negative 0.5, this is my axis of symmetry. So now lastly, I need to find the vertex of this function, this parabola. And so we know once you have the axis of symmetry, you can use that to help you find the vertex. Right? So to find the vertex, remember, we know that it's located at an x value of negative 0.5, and we're wondering what's that y value of the vertex. And to do that, we've been taking our x value of the vertex and plugging it back in for x. So that's what I'm going to do here. Okay. So my y value of the vertex will be equal to 4 times negative 0.5 plus 4 times negative 0.5 minus 3. So I'm going to calculate that in my calculator. I would type it in exactly how you see it with parentheses. So 4 times negative 0.5 plus 4 and negative 0.5 minus 3. And you get a y value of negative 49. So my vertex is at negative 0.5, negative 49. I can tell I'm going to need to use a different scale on my y-axis. I'll count by tens. So this will be negative 10, negative 20, negative 30, negative 40. So if I'm going to plot the vertex negative 0.5, negative 49, I'm going to go down almost until negative 50. And there's my vertex. Now I'm ready to graph. So I'm going to graph my parabola using the vertex and the x-intercepts. And number 5, this is still in vertex form. You'll see that there's an x here. If it helps, you could imagine rewriting this as f of x equals negative 7 times x minus 0 times x minus 6. Right? So that x got simplified here. Right? So I'm going to identify my x-intercepts. Remember, I'm going to use these numbers here to help me get my x-intercepts, right? When x is equal to 0, my function is equal to 0. So one of my x-intercepts is 0. When x is equal to 6, 6 minus 6 is 0. This term is 0, and my function is 0. So my other x-intercept is 6. I'm going to plot those points on my graph. Okay, I'm going to count by 2s so I can get my x-intercept of 6 to fit. So 2, 4, 6. 0, 0 is on the graph, and 6, 0 is on the graph. Now I'm going to find the axis of symmetry. So remember, I need to find the middle or the average of my x-intercepts. So I'm going to add up my x-intercepts and divide by 2. When I do that, I get that my axis of symmetry is at x equals 3. That line, I'm going to graph. I got my axis of symmetry. Now I'm ready to find my vertex. Remember, take your x value of the vertex, plug it in for x to find the y value. So y is going to be equal to negative 7 times 3 times 3 minus 6. I'm just plugging 3 in for my x's. When you type all that in, you get a y value of 63. So my vertex of this parabola is at 363. I'll count by 20s. So 20, 20, 40, 60. And so my vertex will be at 363. Now I'm ready to graph or connect those.